movement that replaced the fusee chain mechanism in order to reduce the thickness of the movement and therefore the watch. Then 3 years later it came out with the tourbillon regulator, 26th of June 1801, the day it received the 7 Messidor year 9. This is with the Republican calendar and with the Gregorian calendar. This is the 26th of June 1801. And what is very interesting is at the time the duration of the patent was 10 years. Now it's 20 years, okay? So he paid for 10 years. And after 10 years, you had the possibility to extend your patent for 10 more years. But he didn't pay. He didn't extend these 2 patents because no one around him could do it.
Of course, that's the best patent.
We had to wait 1 century, 100 years.
Well,
before.
Maybe it's happening the same to you with the magnetic escapement. You know? People have tried.
Exactly, maybe. We had to wait 100 years before other watchmakers came with tourbillon and constant force. Then, after the tourbillon invention, Abraham-Louis Breguet produced, and maybe we can send to you these 4 timepieces because Abraham-Louis Breguet decided to merge these 2 big inventions, constant force with tourbillon. So he produced not only pocket watch, but 4 timepieces. It was a desk clock, marine chronometer, a pocket watch. So he produced 4 timepieces, merging the tourbillon and the constant force mechanism. And the idea of this merged 2 invention was the quest for precision. He wanted to put the best of the best in order to improve the stability of the stability of the accuracy. So it was not only the idea of being precise, the idea was being precise for the entire power zero. And this is why he combined tourbillon and constant force.
And he never developed as much the resonance.
He developed, the resonance. It's not a resonance. The resonance is not.
According to physics, it's not called.
It's not correct to talk about resonance. What is more correct? Synchronization. Resonance is if one frequency. It's like when you walk on the bridge, a military troop walk on the bridge, a frequency will
equals the frequency of the bridge and
but here we talk about synchronization. Synchronization.
You're right. I've interviewed a physics teacher about this in Portugal, and
so you know what I mean.
You cannot say resonance. But in our own, we say
exactly. And all this brandy, when they talk about resonance, that's not correct. So this is why when I said. It's not resonance.
They
it's
call
synchronization.
It coupling with 1 degree of freedom.
Yeah, it's montre à 2 mouvements. This is the right term. So Breguet never talk about resonance. It's montre à 2 mouvements, and he produced 3 timepieces with montre à 2 mouvements with this synchronization, and we have one. We have one in our manufacture. It was actually the most expensive timepiece we bought during an auction. 4 million. And one is in the Buckingham Palace in London.
I didn't know that. I have to go there then.
So only 3 pieces.
Okay, based on the anti-Javier clocks, right?
Yeah.
The 2 pendulums clocks.
Exactly. So
but that's a solution for stability also.
It is also a solution for stability. But coming back to the tourbillon and the constant force, he developed actually 4 experimental timepieces. At the time, he didn't use the term experimental, but he said pièce d'essai. That means prototype or samples. Every new invention was actually a pièce d'essai, and then the language changed a little bit, and we were talking about experimental timepieces. So you can find different type of experimental Breguet timepieces. Subscription, you have some experimental movement. Tourbillon cage, you have also experimental movement. So we decided to take this language for this new collection. And with the experimental number 1, we wanted to combine these two patented inventions of Breguet, the constant force and the tourbillon. But again, the idea was not to copy the past, the idea was really to take inspiration from the past, but with the means of today, in terms of technologies, in terms of materials, in terms of physical phenomena. We have more tools now than before.
But I think this watch is very respectful for the Breguet tradition. It's
so the idea was,
no one else did it. So,
and if you like math, the idea was to find the equation that solves the quest for precision. What affects a watch? First, magnetic fields.
okay.
The experimental one has the Poisson Breguet, so 600 Gauss. That's enough. We don't go with the Breguet to the MRI, machine. Only Omega.
Exactly.
I used to work for Omega, so I'm okay.
Okay.
The doctors were Breguet, not the patients.
Sure.
No. So magnetic field, of course, shock, little shock. The fact that I do that,
Yeah.
just like that, it's micro shocks. It's not a fall of 1 meter on a wood table. It's just putting.
Small perturbations.
Yeah,
So small.
this will affect the rate.
And the
precision.
centrifuge first.
Yeah. So this little acceleration will affect the stability of the rate. We can solve that with the high frequency. And this is
Okay.
why we came out with 10
You can
hertz.
reduce the.
Yeah, you can reduce the effect of the microshocks by increasing the frequency of the balance wheel to 10 hertz. Then the effect of gravity. So when I'm like this during 1 hour, for example, I am in a vertical position, and this is a very common position. Okay, when I type, maybe not, but when I like this, when I have a dinner, a lunch, or whatever,
Where you work
most of the
on
time,
the computer,
yeah,
this
most of the
position
time
right
it's
hours.
vertical position.
Yeah.
So vertical position, we have the solution with the tourbillon. We have the tourbillon. And then what affect also the rate during the entire power reserve, and this is even more important with the hand winding caliber, because the experimental one has a hand winding caliber. What affect the amplitude is the fact that the torque is not stable. The torque is high when the barrel is completely hand wind, and the torque is less important when it's almost empty. So to compensate this effect, this is why we wanted to introduce the constant force. The constant force is a mechanism that delivers a constant force during the entire power reserve. So with the experimental one, we actually solved the equation for the quest for precision, tourbillon for gravity, constant force for stable amplitude during the entire power reserve, magnetism, and temperature. Microshock with high frequency. So we have 4 in 1: magnetic resistance, microshock, constant force, and tourbillon. And with these 4 elements, we can certify that the watch is accurate with a daily precision of plus minus 1 second.
That is incredible. That is incredible.
And this is also the first, and there's another benefit that is linked to the inertial coupling, because the constant force, the magnetic constant force escapement, delivers also the inertial coupling. So that means you can actually put a big tourbillon carriage, usually 10 hertz, 10 hertz, high frequency tourbillon, the carriage is very, very tiny, very small. But here in this case, the diameter of the tourbillon base is quite big. The balance wheel, of course, is quite small, has a low inertia, but the tourbillon carriage is very, very high. This is thanks to the inertial coupling. That means the weight of the cage does not affect actually the amplitude of the balance wheel. And with this magnetic constant force escapement, we can use it not only for a tourbillon, but we can also use it for gearing big disc, things that has a big inertia, big weight. And this is something that we are also thinking about for other applications, not only for the tourbillon, but big data, for example, because such mechanism that has a big inertia affects when you have to turn a big disc. This will affect the amplitude of the regulating organ.
It's very good because now you can put a massive barrel in it.
And absolutely,
super big power.
Exactly.
Super big torque, but not caring about the
stability.
The stability of and the amplitude of
so
the balance.
So the goal
wheel.
was to be precise during the entire power reserve. So we wanted to maintain a stable amplitude.
And without the added complication of actual constant force, more typical constant force mechanism, which also includes a lot of components, and so it's quite interesting.
It's very simple, and instead using the traditional constant force with springs or remontoir d'égalité, we decided to use and to tame magnetism. So we actually developed an escapement, and we basically replaced the pallets, the pallet jewels, by magnets that are made in samarium cobalt. So we had to develop and to choose the right type of magnet. We made different trials and we found the best candidate, samarium cobalt. And then the other very engineering part is the design of the escapement wheel. It's not only one wheel, it's actually two wheels, and each wheel contains a magnetic stripe. And the design of this stripe is very, very unique and was actually designed specifically for this application. And between these two wheels, these two escapement wheels, we have a stop wheel. That stop wheel actually ensures that we don't lose any step, and also it's self-starting. So this will actually solve the problem of most of the complicated escapement, the échappement naturel, natural lift escapement. You have always sometimes a problem of the self-starting. This stop wheels solve the self-starting issue of the escapement. So we have actually only two more components. If you compare the magnetic escapement with the Swiss escapement, you have only two more components. And so the escapement is quite simple, and this is always good when the complication is simple, it's very accurate.
The perfection is when it's not when you can not add anymore.
In French we say it's not a usine à gaz, so it's not a gas manufacturer or whatever. It's really simple, but of course the way how to produce the escapement wheel, because it's quite complicated, because you need to ensure the production tolerances and so on. And the idea with the experimental project is actually to use that technical breakthrough for other movement. So it's not only about using it for the experimental one.
As traditional.
Yeah, exactly. So the idea was actually to implement this magnetic escapement in near future for other.
Miguel was telling me that he was checking the patents, and you had a patent for
Yes.
using this on traditional.
Yes, right? Exactly. Actually, the first prototypes runs with the tradition. Tradition. And when I discovered this beautiful escapement,
it's the natural.
It's more than 10 years development for the magnetic constant force escapement. More than 10 years. So the reliability of the escapement is just amazing. The product is completely new, the concept is new, of course, but again, the idea of the expandable timepieces is to take out the heart of the invention and to use it for other applications. Not only for
what's
tourbillon.
the next obvious step for
The next one?
for the evolution of the stability of the frequency? What can you do beyond this?
You will see in a few months. The quest for precision. Okay. We have different ways. So this is the experimental one. The idea was also to twist the strong Breguet design elements. We wanted to introduce it into the marine collection, but this year or in 2 years it can be a Rendena, can be a classic, can be a Type 20. So the marine is not only linked to the experimental one. The experimental one is actually a transverse collection. But marine important because Abraham-Louis Breguet was appointed to the French Royal Navy as the royal watchmaker, producing more than 70 marine chronometers. And
hence
was
the king of watchmakers and
exactly,
the watchmaker of kings.
Absolutely. And we were inspired by marine pocket watch chronometer with a regulator display. That means we have the seconds at 12 o'clock, the minute at the center, and the hour hand at 6 o'clock. Then we were also inspired by the Marie Antoinette pocket watch. That means all the brass elements were replaced by gold elements, and we also opt for a sapphire dial in order to see the beauty of the movement, the bridges, the gears. And this movement features 2 barrels that are mounted in series, and each barrel contains 2 main springs in order to deliver the sufficient power to the 10 Hz frequency. With only 2 barrels, you have maybe 40 hours, but we wanted to reach 72 hours, so that means 3 days.
There's another brand that exists that did this a few months ago that achieved 31 days. You beat it. Beat 71.
With 10 hertz is a different story. Huh?
But 10 hertz.
That's a different.
And what is also
okay.
What is also very interesting to see is the motion of the tourbillon cage. It looks like 10 hertz. You don't see the jumps. It's 10 jumps per second. So you don't see actually.
See them fading.
So the motion is very smooth. When you look at the tourbillon cage, you don't see any jumps because of the frequency of 10 hertz. And this is the first 10 hertz tourbillon has the base time. It exists tourbillon with 50 hertz frequency, but it's just for 20 minutes. It's just for the chronograph. I'm talking about another brand. But here, the tourbillon 10 hertz is linked to the base time, and this is also a first. All the bridges, all the main plate were crafted in Breguet gold, then coated with the ELD, and then all the bevels are made by hand, polished bevels made by hand. The dial that is made in sapphire is supported by 4 pillars, by 4 gold pillars. And on the other side you can admire the grain finish for the main plate and the bridges, the 2 barrels. Everything is symmetrical. You can see the Breguet hallmark, the Breguet, Poisson Breguet, and also the name Breguet is not engraved but is applied on this little bridge. Then, regarding the case is actually inspired by the fusion between the previous generation and the current marine collection. So the current marine collection, you have this bezel and this link, but of course we have these 2 lugs coming from the second generation. But we decided to twist a little bit the strong design elements, so the lugs are faceted, We have applied also PVD for the crown and this little gold inlay, and also the fluted case band is in 3D. Usually the fluted or the coin age
straight,
design
okay.
is straight, but in this case they are in 3D. So we decided really to completely change and twist the design code, because this is also linked to the experimental program. We want to to twist, to test the market.
Okay.
Also,
have a concept behind
it's
it.
not only about what is inside, it is also about what is outside the product. And you have here the name Experimental One. So it will be a series. So this one is a limited edition of 75 pieces, but the idea is to come out every year with something new in terms of innovation.
Well, and to apply it to others.
Exactly, and then to apply to others. Now we are testing this escapement. It will be not a tourbillon. This escapement works very well with a lower frequency, so 3 Hz, 4 Hz, 5 Hz.
You can use only the escapement on other watches, right?
Yeah.
That's the idea.
Yeah, that's the idea.
Okay.
Because you have to take in consideration that there's a lot of investment in terms of development, and the idea is not to only use it for the experimental program, but also to recuperate this technology for other movements and other watches.
Sure. Okay.
So if you put some gloves, you can really. Yeah. Thank you.
So Breguet now is the most precise watch in the watch industry.
Yes, we can say that. I mean that is also certified with the Poisson Breguet. So plus minus 1 second a day. It's quite impressive. Of course, different position, different temperature,
And so what's next? So now you have the most precise watch in this is a big deal, a very big deal, because there was no such watch with a plus minus 1. These we starting to approach really new.
No, that's for the time being. It's not the goal. Maybe one day we will find a solution to reduce again that precision. But plus minus 1 second a day, it's already enough. I don't think we need to go lower, or maybe one day we will find another type of material or conception. But the idea is to explore different ways. This is one solution, but maybe there are other solutions, Sure. Maybe we can develop other type of escapement or different type of remontoir d'égalité or whatever. We have different fields. The quest for precision has actually different type of children,
We can attack it
exactly.
by many angles.
Exactly, many angles.
We have a watchmaking school in Lisbon.
Yes.
And we always have people with nice ideas and good experience. If someone wanted to make an internship with you, how should we do?
I think we are open an internship. Why not? Why not? Why not? Absolutely.
We'll talk to Aurélie.
Yeah, sure.
The frequency. So you have 10 hertz on this watch.
Yes.
Is there an idea to why 10 hertz? Why did you choose specifically 10 hertz? This is just a natural evolution from 5.
No, we have with the chronometry product. We have already 10 hertz. With the magnetic pivot, we had already 10 hertz. So for the high chronometric performance watches, the base is 10 hertz. So we had already 10 hertz in our portfolio of watches. So this is why we decided also to use the 10 hertz. And we wanted also to prove that we are able to produce a tourbillon as a base time. This is important what I am saying. As a base time, we are able to do a tourbillon with a 10 hertz frequency. This is the first base time tourbillon with a high frequency It exists all the tourbillon with 5 hertz.
Yes,
but this is the first
550,
time.
even,
So we
but,
wanted really also to prove
they are
that
not FaceTime, yeah.
we were able to produce a 10 hertz tourbillon. And again, this is thanks to the having a 10 hertz tourbillon as a base time with such diameter of carriage would be not possible without the magnetic constant force escape.
Okay.
It's really the combination of these two inventions.
And the magnetic pivot. So because it also comes along, you cannot have such high, I suppose, such high frequencies without having this solution in place. Have you looked into other solutions like different types of coatings or different types of material interaction? So I'm talking, for example, you see other brands that use hybrids of inserts of ceramics and things like this, which seems very interesting for the wear of these pieces of the pivots. Have you looked into these also, or this technology that you have now? It's really the.
Don't forget.
I don't know if you
don't
can.
forget the watch is also 600 magnetic resistance. So that means you have also to select the specific materials, because most of the time you have to change the material of the pivot. You know, in this case we use non-magnetic material for the pivot, but then we have different, again, Nivarox is a sister company of the Swalco that produced and developed the regulating organ, not only for us but for the entire industry. And we have developed with them specific materials that has a specific hardness. So it's not just coating; it's about treatment and so on. So there's a lot of knowledges and secret behind this component, this material. Because we need to be sure that the watch will run perfectly, not only after 1 year, but after many years, until the next service comes.
We all share the love for technology. But, how is it possible to communicate all these things that
we don't
they are very
communicate?
difficult to.
Yeah, sure, but we don't communicate. This is secrets.
No, not
Wait,
all of it.
no,
not
we
not
don't
this kind of secrets.
okay.
The technology, the one that everybody knows, the one that says that there's a magnetic escape. How do you communicate that easily? Because we wrote about it, and it's very difficult to explain
It is. We actually play. We have. I don't know if we have the magnet here, but we have a big sample. It's a sample. This is the magnetic escapement, maybe. But the magnetic pivot. But by producing these big samples, you can explain, you can train, you can teach. We have beautiful movies as well. So actually, we play with the repulsion of the magnets. So when you have a magnet here with a north direction, then you use another magnet also with a north direction, you have this repulsion. Attraction or repulsion. So we actually use the repulsions of magnets in order to transmit a constant force to the balance wheel. This is really the goal. So by having the right term, the right definition, but also with the samples, you can actually vulgarize your speech, and you have to define the goal and how to reach that goal. And here we have the solution with this magnetic escapement that produces actually a constant force, depending on the torque of the barrel. This is the invention is great because you have a big torque at the beginning, you have a lower torque at the end of the power reserve, but then the energy that is transmitted from the escapement to the balance wheel will be always the same. So this escapement is actually a kind of filter of energy. At the beginning of the power reserve, the escapement receives big amount of energy, but will transmit the same energy
constantly.
And at the end, it will transmit the energy received.
The
necessary energy. So this escapement is actually a filter of energy. And when you explain that, people, the client will understand, okay, I receive always the same amount of energy, and with this amount of energy, I actually do the impulse of the balance wheel with the same energy, and therefore I have the same amplitude. And by having the same amplitude, I have a constant precision, constant rate of the movement.
That's the way to explain it to customers, to
Exactly.
people that are willing to buy the watch. But what about all the other people that are fans, that only wants to get to know better the brand and to attract new customers also?
Exactly. I think to explain the magnetic escapement, you have first to explain the Swiss lever escapement, the different steps,
the problems that
impulsion, the drop, and so on. So you explain the different step of the Swiss escapement, and then you do the same process with the different step with the constant force escapement, and then you see the differences.
Sure.
And by
explaining the Swiss lever movement escapement, it's not that easy also.
It's not easy, and this is what we did.
It will be difficult to explain it.
And this is what I did during the press conference, because we launched this product in Palais de Chaillot in Paris, Place du Trocadéro, where there is the Musée National de la Marine Française. And in this museum, there is a beautiful marine chronometer that sailed nearly 1 century. Marine chronometers that sail around the world nearly 1 century. So we did the launch there, and there I explained the differences between the Swiss escapement and the Swiss lever escapement with drawings and so on. But of course you have to dive into the different details, and with samples, with drawings, you can explain the differences. You know, watchmaking is always about, having some differences. When you want to improve something, you need to change something. Can be the design, can be the materials, can be both. And here, it's just incredible. The escapement is quite simple. We replace things by other things. So it's designing a new wheels, replacing pallet jewels by magnetic.